green screens. They are used in, practically every single movie that you see to place people in virtual environments. But how the fuck do they work, and why are they green? So the process of green screening has a very cool technical name called Chroma keying, which is actually not that technical of a name because chroma means color. Chroma keying... no, my green screen's falling off. Keying is basically when you remove part of an image, and chroma keying is when you remove a specific color. But the process of chroma key is actually a bit more complicated than it sounds. First, the chroma keyer goes through the whole image, and it sees, is this within my range of color? And if it is, it makes that fully transparent. But if it isn't, it doesn't just make it visible, it makes it white. And this creates what's called an alpha channel. Now your screen right now has pixels that have not 3 values, but 4 values each. There's the red, there's the green, there's the blue, then there's the alpha. Alpha is basically just transparency. So when you create this alpha channel, you're saying, hey, everything in black, I want to be completely transparent. And everything in white, I want to be fully visible. And then you overlay this alpha channel over your video, and you get a video in which you can place over anything and the image will appear in the background. Or on a robe that you're wearing for some goddamn reason. But again, like I said, you can do this with any color. Even blue. And those freaks in Hollywood used to. See, back in the day, when we used film cameras and filmed stuff on film reels, not like Instagram reels, film reels. Like this big circle. The color of choice to chroma key was blue. Now there is a reason for this. First, both blue and green really contrast with skin color. But they also specifically chose blue because back then how they would do it is that they would film the scene on two film reels. One was just the whole scene, and the other was getting the alpha channel. And that film was specifically made not to take in blue. And then what they'd do, they would develop this film in a way to where it would be like we do in our digital editing softwares. We combine that alpha channel created by the film with no blue, and then the real footage. And they use blue specifically because it was simply cheaper to make film that excluded blue. But then we come to the digital era. Now films are digital, and your cameras have a lens in front of them that focuses light onto a receiving screen. I don't know what it's called, but it's a thing that detects light. It's like a screen, basically. But there's a problem with this. Photoreceptors are square, and they only are one color each. And I don't know if you've looked at real life, but what you're seeing out of your eyes is not square and one color each. So we need to particularly arrange these photoreceptors. I don't know what the fuck I'm doing with my hands right now. So we have to particularly arrange these photoreceptors in a way that best captures an image, in a way that makes sense to a human. Introducing the Bayer filter. And yes, it's the Bayer filter, not the Bayer filter. His last name was German. And that's how you pronounce it in German. The Bayer filter is made up of half green photoreceptors and the other half split between red and blue. And this is because we're human. So you know how grass is green, right? So we as humans have evolved to use green as a very contrasting color. We're able to find silhouettes of other animals behind it or in front of green. So the Bayer filter, which is half green pixels, is adopted into pretty much all digital cameras. And so now, some genius I don't know who, was like, well then, this means that we should rethink the chroma keying thing, right? Because now, most of the pixels that are being picked up in the image are green. So it's better to pick up green, or it's easier to pick up green. And green, like I said before, contrasts with human skin tone. And that's why they're green. Green